As people are arriving, we will start with a little short introduction. So welcome to the second training day of the SHAPE EU support program for social and affordable housing district level renovations. My name is Elena. I work for Energy Cities. We are a partner in the European Affordable Housing Consortium. So this webinar will focus on the technical and technological aspects of renovation at district scale. We are working on blueprints or guidelines to assist renovation experts, and today we will introduce them in more detail. Just before we start, I wanted to mention 2 points. So the webinar will be partly recorded and the replay will be available on SHAPE EU YouTube channel. And today we are in conference mode and the audience cannot turn on their microphones. So please use the Q&A section to ask your questions. In the agenda, we will have 2 sections for asking and addressing the questions. So we will use that to bring up your questions. So for today, what do I have for you today? I will start with a short recap about a study that we did in SHAPE EU. We interviewed a lot of stakeholders on their barriers and needs, and I will just highlight a few of the ones that address the technical and technological aspects. And then I have my colleague Nerea here from ECTP. She will introduce the technical blueprint, and she will then focus more in detail on 2 aspects: circularity in renovation and design and architectural approaches at building scale. These 2 aspects will be kind of complemented by 2 best practices, real case building projects. One of them is Schoonship, floating community from Amsterdam. We have Elke here to tell us more about that. And we also have Steven from Art Build Studios here to tell us more about their experience on eco-design and the new European Bauhaus principles. And in the closing, I will promote a few upcoming SHAPE EU events for you. So some of you are probably not aware of what SHAPE EU is, so let me give you a quick introduction. So the European Affordable Housing Consortium, that's SHAPE EU, and we have 10 dedicated partners working for 2 years on this project. We are coordinated by Housing Europe and co-funded by the European Union's Single Market Program. We have 2 objectives, 2 main objectives. And the first one is to ensure that the renovation wave and the new European Bauhaus are socially just and inclusive and affordable, and that the renovations do not happen at the expense of the vulnerable members of the society. And to do that, we have designed a support program, and we are supporting affordable and social housing providers, public authorities, and SMEs to deliver lighthouse renovation districts that include innovative features. And until 2024 February, SHAPE EU offers a one-stop shop for local leaders dealing with renovation topics. We have a peer-to-peer mentorship program. We are developing these guidelines or blueprints. And we have a series of online and real-life events that I will talk about at the end. And the project will also result in policy recommendations on the EU level for the renovation wave and for the new European Bauhaus to be more just and inclusive. So that's all for the introduction. And for setting the stage, I just wanted to share a few of the findings from our report that we did on the local stakeholder needs and opportunities and barriers when it comes to scaling up renovations of social and affordable housing. So here, I just wanted to highlight a few of the barriers. You can see them on the slide, but the main message from our side and from the stakeholders interviewed is that in order to double the annual energy renovation rate that is foreseen in the renovation wave, we need new technologies, we need new tools, new approaches, even new kind of thinking. And that can range from smart building management systems, prefabrication, sustainable low carbon materials, eco-design, and any other technologies, but they have to be mainstreamed when it comes to renovations. So local stakeholders face many obstacles to actually implement all of that. And the challenges range from limited access to funding, low R&D capacity, low knowledge on the local level. And then again, there's also a sort of overlapping, ever-changing building performance standards and regulations kind of complexity. So for us in ShapeEU, upgrading the local skills and competences so that the local stakeholders are able to implement these innovative projects, that is the key for us. And most of the innovations and most of the solutions, we find that they already exist in the market, but they are oftentimes not accessible on the local level, especially when you move further away from the innovation centers of Europe or the innovative cities. So going beyond the business as usual building design and construction and renovation process is what we are kind of promoting here, and also investing extra effort in circularity, sustainability, maintenance, and education of the citizens. So those are my main messages, but the report will be published soon on the ShapeEU website, and there you can read a more in-depth analysis of the barriers. So let's move on, and I would like to welcome Neria and your presentation on the technical blueprint. I will stop sharing my screen now.
Okay, thank you very much, Lina. I will share now my screen. Can you see my screen now?
Yes, we can see it. Thank you.
Okay, perfect. So very good morning to all of you. My name is Nerea and I work as project officer at ECTP, which is the European Construction Technology Platform. And we are also part of the European Affordable Housing Consortium. So today I'm going to introduce you the work which is being done in the technical blueprint, and we'll focus on two main topics. So one of the objectives of the project is to develop these blueprints for replication to deliver successful lighthouse districts. So as Selina mentioned, these blueprints will serve as kind of a guideline for local partnerships on how people-driven approaches during renovation, technical innovation, and planned neighborhood transformation could and should deliver a fair change for communities. So the end goal of this work is to support local authorities, social and affordable housing providers, and also SMEs to learn and advance their own ideas on how to make the renovation wave happen. So we are going to develop 3 modules of the blueprint, as you can see in the slide. On one hand, a GNE is responsible of the project implementation blueprint, whose aim is to detail how to deliver at lighthouse district renovation. Then TU Delft, the Technical University of Delft, is developing the social innovation blueprint, covering all the aspects related to co-creation and co-design of housing neighborhood of tomorrow. And the third module is the technical blueprint led by us, by ECTP, where we propose different technical and technological solutions to ensure circularity and energy efficiency in renovation. So, well, I have to mention that it is still work in progress. We are still working on developing the blueprints, but I can show you that a technical blueprint addresses these topics from regulatory framework and financial model to different technical solutions. So the objectives of this blueprint is to try to give an answer to several questions in the context of the renovation of a district. For example, which are the European directives concerning the energy performance? What are the barriers of modular building systems and how could they be addressed? Why adopt an industrial logic for renovation? How to estimate the smart readiness of a building according to the SRI, among many others. But today, during today's webinar, we will focus only in 2 main topics, which will be circularity in renovation and construction, and then design and architectural approaches at building scale. So first, we will start with circularity. As all of you know, unfortunately, almost 40% of the waste generations come from the construction sector. Thus, it is fundamental to transform the traditional linear economy into a circular economy, in which systems and products are designed to eliminate waste, or the concept of waste, by enabling the recovery and reuse of all materials at the highest value possible at all times. Therefore, we can say that the circular economy is based on three main principles: eliminate waste and pollution, circulate materials at their highest value, and then regenerate nature. So one of the solutions that can be applied to achieve circularity is the well-known strategy of the 5 R's, in which at least 4 actions should be taken prior to recycling. So first, it's rethink to make a product use intensive, then reduce in order to consume fewer natural resources and by consequence produce fewer waste, then reuse to use a product again while conserving its functionality, repair to maintain a product to be used with its original function with the aim of achieving its maximum lifespan, and at the end, as a last resort, recycle to prevent it from being sent to landfill. However, this 5R strategy has been updated, and according to Targets for a Circular Economy by Piero Morselletto, this strategy can be even further developed, adding four more steps, which are refuse, refurbish and remanufacture, repurpose, and recover. On the other hand, another question that we intend to answer within this technical blueprint is how to maximize circularity in renovation and construction of the districts. So the construction and renovation can follow the three main circular renovation actions, which are increasing lifespan, delaying the need for new construction, and reducing the demand for new materials by different actions, which are, for example, retrofitting and increasing the intensity of use, using long-lasting materials, and delaying the building demolition. Another action is to reduce the need for material consumption using resources more efficiently by maximizing reuse and recycling, or using products that comply with the design for assembly principles. And last but not least, making use of new urination materials with high circular potential, as is the case of prefabricated facades, bio-based materials, or nature-based solutions that are living infrastructures inspired by nature and offering a low-carbon alternative to traditional buildings. And just to conclude this part of my presentation, I would like to introduce briefly a good practice of circularity that we are also studying on the technical blueprint. It is the Super Circular State project. So it relates on circular solutions for construction of 4 pilot social housing units in place of 3 vacant and outdated social housing high-rise flats in the city of Kerkrade in the Netherlands. So the process focused on reusing and recycling materials acquired from the demolition of one of these 3 buildings. Since the social housing complex was characterized by valuable materials and social cohesion, it was important to find a way to renovate the area while not hampering these values. It is also important to mention that participation of all potential tenants was key in this co-designing project. Here you can see some images of the project and also the expected main results. And that's all from my side. Okay, so I hope you can see now my slides again.
Yes, thank you.
Okay, thank you. So yes, in relation to what we were discussing, this is why we have these 3 modules of the blueprint, the social, the project implementation, and the technical. Since they are quite aligned, they have codependencies and synergies, and even some certain topics have been difficult to address from different points of view, but we thought that it's fundamental. And one of these topics is the one I'm going to introduce you now, which is about design and architectural approaches at building scale in the context of district renovation. So this topic is being addressed from two different perspectives, one in the implementation blueprint and the other one, which I'm going to focus today, from the technical perspective. But well, I think it's important also to mention that in the implementation blueprint, a vision based on the new European Bauhaus is presented, allowing for a holistic approach to district renovation, taking into account environmental, social, economic, and cultural issues, and thus guiding the transformation of our societies along the three inseparable values, which are, as you can see, sustainability, inclusion, and aesthetics. However, the aim of the technical blueprint is therefore to propose approaches to renovation at the building level that meet these issues while being in harmony with the renovation plan at the district level. So in the context of district renovation, operations at the building level can take various forms. It is therefore essential to apply the principles of the new European Bauhaus to each type of building addressed. So we can have, well, we have existing building renovation, change of use of building, new building construction, and building demolition. And you know that existing buildings can be, of course, renovated to improve the environmental impact and the aesthetics of the building, the quality of private and communal spaces, and the interaction of the building with its neighborhood. Or other purpose could be the integration also of new services. On the other hand, existing buildings can also change as part of a neighborhood renewal. This can involve the conversion, for example, of an office building into housing, or the transformation of disused industrial buildings into offices or even housing. In connection with the renovation of the district, to meet the need for housing and to accommodate new uses, new buildings can also be constructed. For example, this can transform a commercial area with large retail areas and car parks into a multi-use district, including housing, office space, services, and even leisure. And finally, the fourth point is that, well, as part of the remodeling of the district, some buildings will need to be demolished. In this context, selective deconstruction can then prove to be very effective as a facilitator of waste recovery, making this process more efficient, simpler, and less expensive than the realization of a complete sorting after traditional demolition in a sorting center. And well, in this section, we also intend to answer to different questions. For example, what are the best technical and architectural approaches to combine all purposes at the building level, taking into account each of the three principles of the new European Bauhaus? So concerning the sustainability, we propose climate change mitigation and adaptation to achieve a high energy performance, passive house, or zero energy level. Considering the circular economy and the choice of materials at the building level, making residents aware of the new uses of their building, or adding services on the ground floor of the buildings and adapting this strategy for managing the resources and flows of the neighborhood to the scale of the building. On the other hand, taking into account the aesthetics, we highlight two topics. First, the consideration of the original architectural aspects of the building, and then the improvement of the interaction with the building surroundings. It has been demonstrated that it's necessary to integrate the interaction of private spaces with public spaces in order to ensure that the building is well integrated into the renovated neighborhood. And finally, the solutions suggested regarding the inclusion are, for example, the use of industrialized renovation of the district more desirable, improving accessibility to the buildings, improving the quality of life in housing, considering the health aspects, for example, of the inhabitants, and the fight, of course, of the fight against the pollution at building level. Or the fourth one is taking into account the needs of the residents. It is necessary to integrate them in the process of co-creation of the operations at the building level. And this is kind of the summary of this topic, and that's all on my side. So I just want to highlight again that the technical and the free blueprints, it's still work. It's still, well, we are still working on them to develop and to try to have to publish a very effective document. So they will be launched at the beginning of 2024. So I invite you all to stay tuned and to wait for the results of these blueprints. Thank you.
Thank you, Nadia. And next up, I have Stephen from Art Build.
I will stop my presentation. Yeah, no, thanks.
Hello, can you hear me?
Yes, hi, we can hear.
Okay, good. I'll share my screen. If you can just let me know when that comes up for you.
Yes, we can see your screen and the presentation. Perfect.
Okay. All right. Well, oops, I'm just going to go.
Yeah, go ahead. The floor is yours.
Okay. Well, thank you. It's been fascinating listening to these presentations so far. I hope that what I will be presenting will be in line with what we've heard. It's not a story about creating a community per se. It's we're in academia here. We're in the National Veterinary School in Paris. So it's more about creating a demand or satisfying a demand to recreate the soul of a campus, which has been operating now for over 200 years. So just to let you know who I am, I'm an architect. I was trained as a biologist before I went into architecture. I am now one of the partners of a firm called Art Build. We're present in Brussels, Paris, and Luxembourg. We work pretty much all over Europe. And we're one of, I think, a handful of architectural practices who has an internal lab where we do research when we understand that there is a technical problem which has to be dealt with outside the usual design build cycle. We actually have specialist people who try to look a little bit ahead and solve these problems by forming teams with academia, with industry in order to come up with specific solutions. We've been very involved in the timber movement, trying to build, integrate more biosourced materials, and in particular timber, which is the flag bearer of the biosourced materials movement at the moment. So a few figures that you can see on your screen. With recent projects, you can see it's exponential. Mass timber has gone from small projects of 4,000 square meters to 6,000 to 20,000, and now even up to nearly 100,000 square meters of timber, which brings on new questions about where we get, how we manage the timber resource, so that we don't find ourselves in the same situation that we had with steel and concrete, which is where access to resources becomes extremely limited. So I'll talk a little bit more about that, but we've got people working on that. As I said, we have a lab. We see a problem coming up and we're already trying to figure out what we can do. So we're going to land now in one of the western suburbs of Paris. It's Maisons-Alfort. This is the veterinary campus. This is one of the oldest veterinary campuses or veterinary schools in the world. It's been going since 1765. It's an extraordinary collection of buildings. Obviously, veterinary schools have quite a different history than hospitals per se, because all of a sudden, the focus is on animals. So we're sort of coming out of this anthropocentric model about the way in which the universe is constructed, the way in which medicine should be practiced, the way in which health should be practiced. This is all about the application to animals. So all of the buildings on the campus are actually quite purpose-built, and which means that their use is highly, highly specific, and their adaptation to new demands is going to be extremely technical. That's the plan of the campus when it was really at its heyday. So you can see it's a very beaux-arts, a very symmetric, formal layout. Most of the green spaces around the campus were functional to the extent that they would grow their own medicines for the animals. And obviously they had to feed the animals, so they would have prairie and they would have different circuits and everything else. And the building which we were given, which was to become the new center for the campus, the sort of heartbeat, the beating heart of the campus, is that little sort of odd-shaped rectangle with the oval in the middle, which was actually to become the first inpatient hospital for animals, which became then obsolete and was destined to be recycled or reused, or in fact demolished, is what they asked of us initially. But we came up with a solution which is, I think, a little bit more elegant. So that's a Brillant you can see on the screen. That's the one that was labeled for reuse. You can see that the campus has since developed quite a bunch of new buildings around it, which have been delivered for various reasons. The vets themselves, the student vets, actually live on the campus in another building. So unfortunately, we can't really talk about the creation of housing per se. This is very much more of an educational, administrative, and functional building. But this is that quick view of the Brillant building. It was designed by a Dutch architect in the Art Deco style. Extraordinary brick detailing, and also some very, very beautiful ironwork on the windows, which show the animals, the domestic animals, which were welcomed in this building. And for the very first time, actually, outpatients, as I said, outpatients, in this case animals, were brought in with their owners and were treated on the spot. So there was something very symbolic about this entrance, the fact that, you know, hospitals or veterinary schools were open now to public, and they were recognizing that this was a demand, and that care should be extended beyond simply the members of our species, but also should be extended. So we were asked pretty much to demolish this building and to think about certain aspects which we could keep for purely patrimonial or historic reasons or nostalgic reasons. But we thought that there was actually a chance to go a little bit further than that. That's a view of the. Not only do you get a little bit of the brick detailing down below, of course, in the north, in Holland, in northern Belgium, there is an extraordinary level of achievement with this brickwork, which we really wanted to maintain in some way. So what we did was we took the building and we looked first of all at where the existing foundations were, and we thought, okay, well, if we can take this building as a material resource, perhaps we can go further than simply knocking things down, which is the cheapest thing, and then maybe keeping one or two bits and trying to sort of stick them back onto a new building. We thought, first of all, we'll look at the foundations, see if we can build on the existing foundations. So even though we have a radically new program compared to what the old building did, we can actually maintain those foundations. And if we use timber construction, much, much lighter than concrete and steel, we can actually do a minimal amount of shoring up of those foundations in order to build the new building. And that's what we did. So there you can see on the right, there's a scan of the existing brick building. So we wanted to have it really to the millimeter, a trace. You never know. Sometimes you can arrive, the bulldozer's gone backwards, knocked over a thing. These things happen on site. So we wanted the most accurate scan that we could possibly trace or document of the existing building we possibly could find in case anything went wrong. And so that we could, with the new parts that we're going to add, we could be absolutely precise about how we're going to interface with the existing buildings. And there on the left, you can see the inside of one of the brick facades, which we are keeping as we slowly excavate and remove other parts of the building, which could not be kept for various reasons, whether there were pollution elements in the materials themselves or other reasons of practicality. We identified the bits that we thought we could keep, which was structurally sound, and we literally brought out a very, very large circular saw and sliced the edges of what we wanted to keep from what we didn't want to keep. And that's a rather remarkable process to watch happening. It's actually really, it's very surgical. It's something that is deeply satisfying to see incisions being made and choices being made as to what it is that you're going to keep. This is the sort of slightly less aesthetic aspect, which is literally just pulling the materials apart. Glanage des briques, that means you're taking the brick, that you can actually keep the entire bricks, only the full bricks, and then you're taking off the mortar. We had to find a specialist company who could do that, because obviously this stuff usually ends up in landfill. But here we were determined to keep every brick that could be maintained. And this is putting the bricks to one side for their reuse later on in the project. That's an idea of what the foundation started to look like. So we've got this fieldstone foundation, which is actually very, very weak. But with a little bit of concrete poured on the tops, we were able to pretty much sit the new building on top of those existing foundations, with one or two exceptions. But I think that's something which is also extremely unusual these days, given that the carbon footprint of an ordinary building these days mostly goes into, what tips you over in the bad way in terms of the carbon analysis, is the work that you're doing below ground. A lot of concrete, a lot of digging, a lot of energy. Here we were able to really minimize the amount of work that went below ground, below grade. So a few of our partners, I can't say enough about working with people who you've already worked with, in particular the carpenters, the timber contractors, because we had just delivered a mass timber building in Nantes. So we had an idea of how much prefabrication could be optimized, given that this site, again, this is a working campus, a veterinary campus, veterinary school. So we had to do all of this work with the campus operating around us. We realized that if we could optimize the prefabrication of all of these timber elements, we could really increase the speed of construction. With a timber contractor, you're also talking about 2 people on the ground and 2 people in the air when you have your mobile crane. So you're reducing enormously the amount of resources that you have to put into the project, whether it's human resources, material resources, but also the number of rotations, the number of trucks which are going to be coming is going to be limited by about 80%. So it's really working with specialist contractors in timber is an absolute must, especially if you've got the shared culture of working together and trying to see how you can optimize each element of prefabrication in order to make it the most appropriate possible. So a little timeline, the competition was held between 2018, 2019. We were fortunate enough to be able to get the project awarded to our group, 4,500 meters squared of new construction, 14.7 million. I think these are useful figures to have in mind. It's interesting to compare this sort of approach to conventional new builds, I think, because obviously finding somebody to chip your little bricks and to keep as many bricks and to set them to one side, it's not a usual practice. Trying to find the economic margins in order to get that to be possible means quite a lot of sort of work with your contractors and with your client. But again, these figures, I'm including them in the presentation because I think they're important for different actors in the sector in order to be able to look back on what was done and to see if it's viable in other situations. This is the program. Three basic elements to the brief. There's sort of what they call the forum and the life of the school. These are the amphitheaters. This is where people come to get together and to talk and everything and to exchange. Then there is the pure teaching modules. You'll see a couple of photos of those later. And then there's the administration. So the staff was also looking for a new home with offices which were up to today's standards. I won't go in too much go into too much detail about what the existing campus facilities were like. Needless to say, they were desperately in need of renovation and a little bit of tender loving care. That's how the brief elements were sorted out from a plan point of view. So we have to the left the forum, that's the main entrance, that's a historic entrance with its 2 amphitheaters, 350 people. Underneath them go the loos, the toilets and everything else. In the middle, we have mostly the direct teaching. So we're not in the sort of the big amphitheaters, all that flow that comes and goes on a daily basis, but we're in much more of a sort of an intimate teaching environment. And then to the right, the administrative staff, the meeting rooms and the offices. What we were very careful about was not to put the different sectors of the brief into silos. you'll see some pictures of the corridors, which we tried to conceive of as interior streets, where there's this constant exchange possible and transparency between the different elements, the different rooms, the teaching facilities, so that there's a constant interface between the people who are using this building. And I think this is also, we talk about biophilia and the importance of having things which remind us of nature and to see through to trees, to see through to nature, to have natural light, and that's all very important. But seeing human beings is also very important, and to realize that there are things going on and that there is activity going on. I think this is also absolutely critical, and I hope that the photographs will share some of that. This is the building now, which is finished, and you can see the sort of mixture of recycled brick and some of the references to the Dutch mastery of brickwork, which we tried to build upon. We also, the connections to the outlying buildings and where the flows were going to come from, we tried to sort of cut into our new building to show where the entrances were, in order to encourage those flows or to address the existing flows on the campus. Much of campus design is about flows, really, and about making it as efficient as possible for people to get from one place to the next, and to make that experience as enjoyable as possible, including the stairs going up and down. This is a building of basically a below grade, then ground floor plus one floor. So if you can see on the right, we integrated what's called a chambord staircase, which is where you have two staircases in the same volume. So in fact, you can meet people even when you're going up and going down at the same time. And we thought that that was quite important as well, to go right to the end, right to the limit with the idea of mixing spaces. So we're now getting into the finished product. This is the main foyer. We got the amphitheaters on either side, and then we had this little courtyard space, which is going to grow. I mean, it's got its trees and its natural elements included. Lots and lots of natural light, and again, all of this is really done optimizing various timber methods of offsite manufacturing. I won't have time to go into much of that. You'll see it broken down in different images, but monumental stairs, really the idea is to encourage people to see each other as much as possible. This is the chambord staircase, one of the very few places where we poured new concrete, but that's necessary for fire regulation now. I think that's becoming a universal constant now across the different countries who are involved in mass timber. These are some of the flow patterns. And the corridors are designed to have as much natural light as possible to see what's going on in the rooms around, and to have, here we've got light coming in from the roof. So we wanted to have this constant presence of natural light wherever it was possible. So you don't feel as though you're entering an academic building and you're not going to see the light of day until the end of your courses. We wanted something that to be absolutely present, omnipresent. This is how the principal facade, the old ceremonial entrance, turned out. So it's quite clear where the new brick has been positioned compared to the old brick. So, you know, it's rather like a palimpsest. You're sort of rewriting, a new shape, new volumes, and new textures onto an old thing. And we felt that somehow that we were able to sort of achieve the sense of gravitas of this monumental entrance, even though we're adding a completely new functionality to this entire process. But you can also see, if you've got the trained eye, that there are ramps for handicap access, for a wheelchair. So when this building is also being opened up in order to respond to a number of usage patterns which were not at all present in the building previously. There's a little bit of an idea of how the ironwork was maintained. Again, these are now fire egress doors, so you're converting old doors which are not either thermally sound or acoustically sound, or from a functional point of view, fire sound. Somehow you're able to find solutions in order to make them work and still remain in the architecture in pretty much their original thing. So that's quite the challenge. But again, don't have enough time to go into too much of that. I love the ironwork. I think it's absolutely gorgeous. Their little zoom of the dog's face. All of this was done in a very, very highly developed Revit model, 3D model. So we had a dynamic model telling us what was going on. One of the good things about reusing the brick is that you're getting a lot of thermal inertia timber buildings tend to have this problem of very low thermal inertia. So they will heat up and cool down very fast, which is not a good thing when you're trying to maintain a level of stability, particularly in the hotter months of the summer. So the fact that we had a brick skin on the outside of this building was beneficial. And again, this 3D model was able to give us an extremely accurate reading of what was going to happen and how this building was going to perform. It was not just a design and build, but design and build plus the maintenance had to be integrated into the design and into the commercial offer that was made by the lead contractor. We integrated a lot of biosourced materials. You can see in between the timber panels, those are biosourced acoustic panels. We pretty much used biosourced materials everywhere that we could, where there was a choice, even including glass bricks in the existing, in the ways in which we put the brickwork together again, so that there again, this is constant presence of natural light diffusing into the spaces. Even the darkest spaces, we're actually able to get the natural light. So we're actually quite proud of those little details. A little picture of the amphitheater. One of the main amphitheaters, again, lots and lots of timber for its biophilic effects. Thought I'd include a couple of shots. Yeah, timber workplaces are very, very popular with contractors. We've had buildings where we've been doing a concrete building next to a timber building, and the workers actually come to work on the timber. Will come to have lunch on the timber building site because they love the smells and because there's just a generally good feeling about it. So it's a real pleasure to visit a work site when the timber contractors are on site. I'm going to skip over those. That's a little bit more detail about what happens in the teaching spaces. There's a little bit of an idea. Those are not real animals, by the way. Those are animals that veterinary students practice on. But they nevertheless have to be accommodated. Again, few views of the corridors and the circulation spaces to show that you can see what's going on, and the idea of a transparency and inclusivity in the whole approach is something which we work very, very hard on. That's where the certificates are given out in a formal way at the end, right next to the little courtyard. So again, when people are getting being given their diplomas, they're in full visibility of the public and other people around. So I've included a few of these slides for those timber fans who may be interested in seeing how things are going. I loved, Ilke, thank you for that dovetail joint. I think it's great to see thinking about potential reuse from the word go. These are some of the breakout spaces. Again, this is a corridor which we transformed into a place where the students can meet, can work, can talk, discuss, and make the circulation areas much more like a public space rather than simply a place to get from one end to the next. A little bit more idea of how that's the administrative side. Again, even the administrative guys get a little bit of breakout space and a little bit of public space in their plans. That's the administrative side. We tried to keep all the buildings, all the trees rather. We didn't pull up any trees. We just had to cut a few back a little bit, and we tried to set some of the outside terraces wherever we had large trees growing, so that again you could feel the protection. There's another one that's on the other side, the rather hidden side of the building, but all of the little terraces feature these shading, the natural shading devices called trees. These I've included because they show you where the timber goes and where the brick has been assembled around the outside. This is actually a load-bearing timber construction peripheral wall. The brick is only holding up its own weight. To do this, we had to do a lot of research. We had to do what's called an ATEX. I'm just going to flip through these slides just so that you can see a little bit the way in which the building was put together. We had to do what's called an ATEX, which is a combined effort by the contractor and the various people working on the project to convince the building controllers that we have pretty much the answer to every question that they might have about how the composition of brick, recycled brick in many cases, is going to work with the load-bearing timber on the inside. That might seem to be common practice in countries like Holland and in countries like Britain, even in Belgium. It's not common practice in France, and so we had to literally create an encyclopedia of details in order to convince the building controllers that there wouldn't be any problems of infiltration or movement or settlement between the two load-bearing elements, the brick carrying its own load, the wood carrying the rest of the construction. We have a roof which is PV ready. We didn't actually need any energy according to the brief demands, because we have a collective energy being brought from the community called the CPCU. So it's a cogeneration which is providing the energy necessary for the running of the entire campus. So we were quite lucky. We didn't actually have to produce any energy in situ, but we're ready. The roof is ready to receive PV cells if there should be an increased demand. This is an idea of what this ATEX I was talking about, what you need to do to prove to the building controllers that this is all going to work and there isn't going to be any problem with the functioning of these two reconstituted elements. So just to finalize, one of our inspirations for the project was this painting by Gustave Courbet, which is called La Chaîne de Flagey. He had originally painted it with a hunting party, with people, with men on horseback, with dogs and everything else. And as he got further into the painting itself, he began to realize that the only thing that he wanted to show in its majesty and beauty was the tree. He did not need to have the humans around in order to make the picture attractive. He wanted to ennoble what he called the brute, the raw. He wanted to magnify and to show off the simple acts of nature. When we were first talking to vets, they described themselves as the poor cousins of doctors. And they say, we work in rustic environments, in less noble environments. And we set ourselves this task of trying to do what Courbet did in his painting, that is to take the rawest elements, recycled brick, timber, natural resources, and even what the vets themselves do, and to try to magnify that and try and make it, using a new vocabulary, into something which becomes noble and leaves behind this rather awkward notion of being leftovers or poor rural cousins. And I hope that in this presentation I'm able to show you that you can do dignified things with recycled materials. And those are the vets in their new school since last autumn. And I'm going to leave that picture on the screen, I think. I'm going to say thank you. Thank you very much for listening.
Thank you so much, Stephen. Beautiful presentation and wonderful last message. Really, really inspiring. I hope that the audience also found it inspiring. For me, the one thing that I got from this presentation was really how the building design can facilitate the social interactions and the openness. And I think it's very important also when it comes to housing, especially social housing. And I would want to ask you, you already mentioned a lot of these circularity principles that you used and these aspects, but what would you say would be the most useful and most impactful when it comes to residential building design? You talked about,
I think, the focus of this presentation was really on technical aspects, trying to make these awkward decisions about what you can keep and what you should throw away. Or, I mean, you know that these things are going to go into channels which are not as virtuous as you'd like them to be. So these are tough decisions. I think with a lot of housing stock, and I think if we look at what the big challenges are today, a lot of the housing stock is heritage to some extent, and we don't have the same regard of housing as we do with office buildings. We see them as patrimonial. We see them as they're built to last forever. A lot of housing stock in Paris is brick. And we want to keep that brick visible. we need to find these solutions which enable us, rather than sticking thermal insulation on the outside, we need to look at ways in which we can combine elements and maintain the patrimonial value of that brick, particularly for the housing sector. And that's not easy. That's not easy. If you look for the cheap solutions, you're pretty much talking about putting insulation on the outside, and you lose that charm which a lot of cities have. And I think that would be desperately sad to lose it. So again, we need to work very, very hard on finding these solutions which enable us to maintain the soul, but yet also to inject that innovation which timber construction and which biosource materials enable.
Yes, wonderful. 100% agree. Thank you so much. Do we have any more questions? Let me look at the...
Can I ask a question of Ilka? I was going to ask this before, but was the choice of living on water, creating this community on water, was that a land use thing, or was it just we want to be on water because it's it's going to be cooler on water, it's global? I mean, what was the driver between choosing to live on water?
Well, it's a little bit less fascinating probably than it seems. It was simply a place that was available. And it was, well, no, not fully true. The 4 people really initiated the project, and the one person who started it off, she made a document. She's a documentary maker, and she made a documentary about an Antarctic floating home. And she got so inspired that then she asked the question, "Can't we do this on the water?" So basically, that's the idea. But generally, it's sometimes referred to this to climate change and adaptive and so on. But that's not the case. It's simply, an inspiration thing.
Okay.
I don't see any questions, but let me check again. There is one question. I'm curious if it was difficult to arrange parts of the building in response to existing natural elements like the terraces near the trees. Did this inconvenience the process?
Yes, trees is always they're always a problem because the contractor wants to take them out and replant. One of the unusual things about this campus was that even though each building itself is a gem, architecturally, the only thing that was listed from a heritage point of view and that we had to keep was the ground plane. That sounds really, really strange, but it was the ground plane that was protected. So the nature of the ground, sometimes it's packed clay, sometimes it's stone pavers, that was protected, and we considered that the trees themselves had to be protected in the same way as the ground plane. They're part of the ground plane. So we were enabled to put forward arguments to keep the trees. Okay, they had to be trimmed back in order to allow for the movement of the cranes and everything else. But those trees, we didn't tear up a single tree. We were able to keep all of those beautiful, beautiful old trees, chestnuts, and a really wonderful collection. And study them as possible shading devices or as future shading devices, which they then came to be. So yes, that was a big challenge, but it's easier these days to defend a tree than it was 10 years ago.
Okay, thank you for your response. Any more questions? I guess it takes time for people to write, so I'm gonna wait for a few minutes.
Yeah, one thing I didn't mention, the recycled brick, actually, when we put obviously the bricks and mortar had been assembled in a particular way in the original design. When we took them apart, we cut down the amount of mortar in the way in which we recycled or we rebuilt those brick walls by about 80%. So we were only using a fraction of the amount of mortar. So in fact, if you look very, very carefully, you can see that there's a sort of a big gap between each brick, and the mortar is only really at the very, very back to sort of hold the thing together. But that was also a sort of a circularity theme, which is very important, because the next person who comes along, if they want to reuse the bricks, it's much easier for them to literally deal with the masonry, rather like Lego. So.
And let me share my screen for the next part. Okay, there it goes. Yes, so thank you very much again, both of you. I think that by looking kind of outside of the business as usual renovations, we can get some inspiration to then bring back to the renovation projects and do better and build more beautiful, more energy efficient buildings. For this closing part, I just wanted to bring up the events that are following in Shape EU. We have a kind of a packed program for the remaining year. So the training days there's a program and series of online webinars, which are these training days where we introduced some great examples plus the content from the blueprints. And that is going to happen throughout the year. We have 5 in total. And we also have finance webinars. There's one coming up today, later today from 2 to 4. And there we will talk about financing of district level programs, specifically for social housing. And something that might be interesting for the audience, we have an Affordable Housing Initiative Tech Camp coming up during the Social Housing Festival in Barcelona, June 7 to 9. And this event is really dedicated to addressing the difficult technical challenges related to renovation, such as market solutions, sustainable solutions, materials, advanced technologies, and etc. So for the capacity building sessions, we have the training webinars, the finance webinars, the tech camp. We also have study visits. There's one coming up in Paris. The applications are still open till May 12th. So if you go to the Shape EU website, you can still apply to that. And there we will see 2 great examples of affordable housing renovation projects. We have another study visit coming up in Vienna in September. Let me change the slide. Yes, so in Vienna we have a boot camp coming up and a study visit. The boot camp that's a special event concept based on peer-to-peer learnings and exchanges, which in essence will work as an intensive training to drive the district level renovation scaling. So yeah, that is all from my side. If you want more information about the upcoming events, I would suggest you to follow Shape EU either on LinkedIn or subscribe to our newsletter. And of course, all the information is available on our website. Thank you so much to all of the speakers again. And if you have any questions, be sure to email me. I will put you in touch with the speakers if needed. And yeah, have a great day.
Thank you very much.
Thank you very much.
Thank you.
Thank you. Have a nice day.